Hello, everyone. My name is Jared Thorne, and here's my presentation for Lab 2 of Physics 2212. This lab deals with charged everyday objects and their interactions. The goal of this lab is to observe the transfer of electrons and determine the amount of excess charge on a piece of charged clear tape. Different from Lab 1 is that we no longer treat the charged tape as a singular point charge, but as a collection of evenly distributed point charges. So basically, we're going to create pieces of tape that are charged, then observe their interactions with each other and then with other objects that are differently charged. After doing this, we're going to apply the concepts that we've learned in class, such as Newton's law, electric force equations, and electric field equations, all to determine the net electric and gravitational forces acting upon the tape. We'll also create a glow script model of the interactions. Some concepts and equations we'll use for this are Coulomb's law, which tells us that similarly charged items repel while opposite charges attract, and also that the electric force between two charged objects is directly proportional to the charges on the objects and inversely proportional to the distance between the two objects. Also, the conservation law of charge, which states that charge can't be created or destroyed, only transferred between objects. We also remember that the neutral objects are attracted to charged objects. Other equations include the ones shown on the screen, the electric field equation, the force of gravity, and the equation for Newton's second law. When it came to the procedure, I cut pieces of tape, then laid them on top of each other. It is important to touch the tape as low as possible so you don't transfer any charge from your hand. I pulled the tapes away from each other. I could tell the tape was then charged since when I brought my hand close to the tape, it would float closer to my hand. To test this again, I made a plastic pen negatively charged, then brought it close to the tape. The tape again floated towards the pen. I then brought the pieces of tape close to each other, at which point they repelled. I then measured and recorded the distance between the two pieces of tape. My assumptions for the procedure are that we assume Coulomb's law actually works for our experiment. We assume that the U-tapes have the same net charge. We're treating the tapes as if their all charges are spread evenly along the tape, and air resistance is negligible. As I mentioned before, negatively charged objects attracted to the U-tape, such as the pen in my hand, while the tapes repelled each other. Here are some of my constant observations from my experiment. My tape was about 0.2 meters. The width of the tape was 0.023 meters. The distance when the top tape began to float was 0.017 meters, and then the charge on the U-tape was 7.93 coulombs. Finally, here are my calculations using the figures from the previous slide. In the simulation snippet, you can see the electric force from each particle in green, the net electric force on the tape in white, and then in yellow, we can see the gravitational force on the top tape. The electric force was calculated to be 0.0024 newtons, and the gravitational force was calculated to be 0.00196 newtons. As you can see, the net electric force and the gravitational force are very close, but the net electric force is a little bigger. This makes sense because when we measured when the top piece began to float, that showed that the force exerted from the bottom tape was bigger than the gravitational force, causing it to move upward. Here's my glow script model. After inputting my constants and observed values, we calculated the electric field emitted from the tape and calculated the rod of point charges. Finally, we can see the implementation of these two methods. We calculated the electric field emitted from the tape and then calculated the rod of point charges here. We can see the implementation of these two methods in two loops. The outermost loop accounts for individual particles in the top tape, while the inner loop accounts for individual particles in the bottom tape acting upwards on the top tape. Finally, to answer our what if questions. In this lab, the tapes were not simulated as point charges in the first lab to better represent the distribution of charges across the tape as a whole. This is a much more accurate representation of the charges in the tape compared to in lab 1. These estimates are different from each other because each portion of tape does not exert an equal force on every part of the tape. For this reason, the calculations yielded different results than in lab 1. Thank you for viewing my lab report.